Okay, folks, this next video for the motion graphs is about acceleration versus time graphs. This type of graph will show up in a few units this course, and we don't use it as much as velocity versus time, basically because it does not give us as much detail as the velocity versus time graph does. Okay, so being an acceleration versus time graph, it tells us the way in which the velocity is changing. So acceleration is change in velocity over time. And so when I look at a value for acceleration, it's telling me the way in which the velocity is changing. So segment A has an acceleration of 1.5 meters per second squared. And so the velocity is getting more positive. For segment B, the acceleration is 0, and so this is constant velocity. And then for segment C, this line is underneath the x-axis at -1 meters per second, and so the velocity is becoming more negative. Keep in mind with what we said about velocity versus time graphs, that just because the acceleration is positive and the velocity is getting more positive, doesn't tell you which way the object is moving. There's no information on this graph about what this would even look like. This could be an object that is slowing down or speeding up in segment A, and it could also be an object that is slowing down or speeding up in object C. We would need more information than this graph tells us to know what the object's actually doing. The other thing you might notice is that this graph is not continuous. So you will commonly see acceleration versus time graphs just skip around, and that is more or less to avoid calculus, and therefore avoid reality. No object can go from an acceleration of positive 1.5 to an acceleration of 0 without having acceleration values of everything in between that. So we use graphs that look like this when we do math to make our math easy. But what is more common is you would see an acceleration versus time graph that would look like this, except there'd be some curve and drop to the acceleration there, and then maybe another curve and drop to the acceleration there, to recognize that the acceleration doesn't happen instantaneously, that changes can happen quickly, but they do involve incremental change. Okay. So we know some basic info about the graph. We know this acceleration equation looks like this. If we rearrange this equation, we can solve for delta V. And we have a very similar situation to our velocity versus time graph. Our velocity versus time graph told us displacement by calculating the area under the curve. The acceleration versus time graph can tell us something different in a very similar way. So the change in velocity is the area under an acceleration versus time curve. So this is the same idea as when we did velocity versus time. The area under that graph was the displacement. This time it's the change in velocity. Now, in AP Physics 1, we kind of stop with the changes here, and so all of our acceleration graphs are going to be flat for now. Later in the course, we will deal with acceleration graphs that are not flat, and we will deal with them not mathematically. But for mathematical treatment, we can use this concept. So just to give you some sense of this, if I wanted to find the change in velocity from t equals 1 second to t equals 8 seconds, here's what I would do. So I can define the left bound as 1 second, and from 1 second to 4 seconds, there is a positive acceleration. So we'll do delta V 1 to 4 seconds. Now that's going to be the area of that rectangle. So that's going to be base times height. So that's 1 to 3 seconds. times 1.5 meters per second squared. So this one is acceleration times time gets you a velocity. So 1.5 times 3 is going to be 4.5 meters per second, and that's going to be positive. From 4 to 6 seconds, there is no change in velocity. I don't need to calculate anything because I have a flat line at 0 meters per second squared. For the last segment, I said it was going to be from 1 to 8 seconds, so this is going to be from 6 to 8 seconds. So 6, 7, 8, and I just define that as my space. So that's going to be another rectangle. This is going to be 2 seconds with an acceleration of -1. And so my change in velocity is -2 meters per second. So my total change in velocity from 1 to 8 seconds is going to be positive 4.5 meters per second plus -2 meters per second. So essentially 4.5 minus 2, I skipped the 0 here, I have a positive 2.5 meters per second. Again, so that's how you would work with it mathematically or quantitatively. Again, we don't know anything beyond this change in velocity. We have no idea what the initial velocity was. So, if the initial velocity was like positive 10 meters per second, then this object sped up, had constant velocity, slowed down, and is still moving with the positive velocity. But if the initial velocity was -5 meters per second, then the end result is that this object is still moving in the negative direction, just more slowly. And so we will put a lot of this all together qualitatively in the next video. But that is all of the core concepts that we're going to put together in this part of the unit.